So we drawn this on the back of 9.5. We're going to solve for the missing values and round to the nearest tenth. So on these, the first thing you want to do is label your sides from the angle they gave you. So what kind of side, which one of these is the hypotenuse? Y is the hypotenuse. Which of these is the opposite? 12, which means x is adjacent. So once you have labeled the sides, you want to pick a side you don't know and a side that you do know. So which side do you want to solve for first? X sounds good. And then which side do we know? 12. So we need to use either sine, which is so, cosine, which is ka, or tangent, which is toa. Which of these deals with the opposite and the adjacent? Toa, tangent. So we're going to use tangent from 25 degrees, and it will equal the opposite over the adjacent. Opposite over the adjacent. Can I multiply both sides by 12? No, I need to flip both. So flip both sides. Once you've done that, you can officially multiply by 12. And then we're rounding to the nearest tenth. What'd you get? 28.4. Did everyone get 28.4? Okay. Did anybody not get 28.4? Everyone got it? Did not get 28.4? Yes. All right, what'd you get?
7.
Yeah.
That's 410. Oh, my bad. I was doing sin.
Oh, okay.
That's my fault.
25.7. It's okay. That's why I asked. Did everyone get that? Good. Okay, so 25.7. I see. You did the other one. We want now to find y. You still want to use the side you know and a side you don't know. So we'll go back to using 12. Which trig ratio is going to deal with these two sides? Sine of 25 equals the opposite over the hypotenuse. Can I multiply both sides by 12? No. Going to flip. And then multiply by 12. So then what do we get this time? 28.4. Oops, sorry. What letter was this? I put X, I'm sorry. Let me fix it. It does matter because, you know, some people get the right number for the wrong side, and then that means it's wrong. Do you know what I mean? So just make sure you label X and Y. So that's that. We're going to go to page 2. Page 2. So essentially, we're going to find sine of S, and we will also find sine of R, and we will find cosine of S, as well as cosine of R. That's our goal. I would do one angle at a time. So we can do from S first, because that's the first one that's listed. So you want to label your sides. Which of these is the hypotenuse? 65. Which of these is opposite? 63, which means 16 is the adjacent. So we're doing so and ka. So sine will be opposite over the hypotenuse. So 63 over 65. This does not reduce. But what is it as a decimal? It says rounded to 4 places. So point 9692. Perfect. Now we'll find cosine of S. Cosine is adjacent over hypotenuse. So what will go in the numerator? 16, and in the denominator, 65. What is 16 divided by 65? 2, 4, what? 6, 2. There you go. All right, so those are sine and cosine for angle S. Now we will find sine and cosine from angle R. So from angle R's perspective, which of these sides will not change? The hypotenuse. But what will change, what is opposite of R? 16, which means 63 is adjacent. So then for sine of R, the opposite will go up on the top, 16, over the hypotenuse, which is 65. This should look very familiar. What is 16 divided by 65? 0.2462. And then cosine is adjacent over hypotenuse. So adjacent is 63. Hypotenuse is still 65. What is 63 divided by 65? 0.9692. So you should notice the repetition there. It's because there is a relationship between sine and cosine of R and S. So I'll show you why. How many degrees do R and S add up to? 90. And here's why, right? 180 in a triangle. There's already a 90-degree angle in it. Subtract 90. That means there's 90 left. What do we call two things or two angles that add up to 90? The other one. Complementary. So these angles are complements of each other. So here's what you're going to learn, just like we see here. I'll just take these two as an example. Sine of whatever angle S is will be equal to cosine of whatever angle R is. And I'll show you with numbers. All right? S and R represent angles, right? S represents this angle, R represents this angle. And again, we know these angles add up to 90 somehow. So I'll show you with easy numbers how these are equal. Sine, we'll do sine of 40, will be equal to cosine if angle if angle S was 40, what would angle R have to be? 50. These two will be equal to each other, and I will show you. We'll have this half of the room, like this row over. Go ahead and type in sine of 40. This half of the room, type in cosine of 50. And we will see what we get. So you typed in sine of 40. You guys typed in cosine of 50. Let's round 4 places again. What did we get for sine of 40?
0.6428.
0.6428. Good. And then what do we get for cosine of 50? 0.6428. Do you see how these two are equal to each other? So here's what it's going to ask you. It's going to ask you to rewrite sine in terms of cosine and rewrite cosine in terms of sine. It's very easy to do. You write the other word and then you subtract from 90, and those will be equivalent to each other. Okay, so I'll show you with this picture. This is what it looks like in your book. For any of these, so we have A and B in this one. Sine of angle A will be equal to cosine of whatever 90 minus A is. Okay, that's what angle B is. So again, we'll show you here. Sine of 16 degrees would be equal to cosine of what? Of 74 degrees. So this half of the room, type in sine of 16. That half of the room, type in cosine of 74. All right, so we got
2756.
Perfect. 0.2756. Did this half of the room get 0.275? Yeah. So what you're going to be asked to do is rewrite sine in terms of cosine and vice versa. Cosine in terms of sine. So you see what I boxed in? This would be like your answer. Not necessarily. I'm just showing you why they're equivalent to each other under it. So this is the last part of this section. We're going to write cosine of 23 in terms of sine. So we're going to write sine first, S-I-N. And then to figure out what it is, you would do 90 minus 23, which is 67. So that means those two are equal to each other. You can always plug them both in to see that they equal, to check. And then last, write sine of 56 in terms of cosine. So cosine, and then what is 90 minus 56? 34? Beautiful. I will tell you the most common mistakes that people make when answering this question. Some people don't put sine or cosine. So let's just all take a second. Some people, like when they rewrite it, they're like, oh, this is equal to 67 because 90 minus 23 is 67. But if you type this into your calculator, just type it in really quick. What is cosine of 23 degrees? 0.92 is a decimal, right? Is that equal to 67? It is not. So please make sure you have the word sine. Other things I see is people put like an equal sign here for, I don't know what reason. Remember that you have to have an angle next to sine or cosine. That's how that works.